Let's solve all of the relay questions from the 2024 ARML. Okay, problem 1. Compute the number of positive integers less than or equal to 100 that are not multiples of 2 or 3. So how many multiples of 2 are there? So there's going to be 50 multiples of 2, and there's going to be 33 multiples of 3 between less than or equal to 100. And there's 16 multiples of 6, which are multiples of both 2 and 3. Okay, and so to find the number of positive integers less than or equal to 100 that are multiples of 2 multiples of 2 or 3, we do 50 plus 33 to count 2 and 3, but we're overcounting the ones that are multiples of 6, so we have to subtract that. And in this case, this number is going to be 67. But in this case, we're counting the numbers that are not multiples of 2 nor 3. So we have to subtract this from 100. And so our answer is 33. Okay, so person number 1 in the first relay problem will pass on the answer of 33 to person number 2. Okay, now let's solve problem number 2 with the information that t is 33. So ARML is a square with side length 33. And let S be the set of all points P such that a circle of radius 1 centered at P lies completely within ARML. Compute the area of S. So turns out that S is just this region. But how do we know that? Okay, so if the point P is outside this region, then the circle isn't going to fit entirely because there's going to be some point over here. But if P is inside the region, then clearly it works. So what's the area of this region? It's a 31 by 31 square. Because the center of the circle must be at least 1 unit away from each side of the square. So the region is a square with side length t minus 2. Because this has to be 1, and this has to be 1, and this has to be 1, and this has to be 1. So then it's the answer for that person 2 will pass on to person 3 is going to be 31 squared, which is 961. Okay, now let's do question 3 with the information that t is 961. Let t be the number you will receive. For some positive integer k, the number of subsets of 1, 2, 3, k that contain at least one even number and at least one odd number is t. Compute k. All right. So let's see. So we want to find, so we can just test out a value of k. Let's just say k is like 11 or something. Because then the number of subsets that have at least one even number, well, there's going to be 5 even numbers inside 1, 2, 3, k, and there's going to be 6 odd. Okay, so then the answer is, from the 6 odd, we need at least one of them. And from the 5 even, we need at least one of them. So we have 31 options to choose from the 5 even, and 63 options to choose from the 6 odd. So then if k is 11, then our answer is going to be 31 times 63, which is larger than 961. So k is less than 11. Okay, so k is equal to 10. In this case, there's 5 even and 5 odd. And so if we want to choose some even numbers so that there's more than 0 even numbers, then that's 2 to the power 5 minus 1, which is 31. And here it's also 2 to the power 5 minus 1 is 31. Because we want to choose a subset of 2, 4, 6, 8, 10. This is the example for the even. That has at least one of these members in it. And that's 2 to the power 5 minus 1 by complementary counting. And so the product of these values is 961, which is this number. So therefore, k is equal to 10. So the answer to this problem is 10. Okay, so now let's move on to relay question number 2. Let's see. Compute the greatest perfect square that divides both 10 to the power of 20 minus 1 and 10 to the power of 24 minus 1. Okay, so if this perfect square divides both of these, then it must divide their difference, which is 10 to the power of 24 minus 10 to the power of 20. And this is 10 to the power of 20 times 10 to the power of 4 minus 1, which is equal to 10 to the power of 20 times 99 times 101. So if we want the greatest perfect square that divides this, 101, there's no other factors of 101, so we can eliminate that. Also, we can see that 10 to the power of 20, n cannot have any factors of 2 and 5, because n divides both of these as well. So therefore, the answer is going to be 9, because because the thing is, n cannot have any factors of 2 and 5. So the 10 to the power of 20 thing doesn't matter. So n must divide this. And so then, the 101, so n divides 99 times 101, but 101 prime, and there's no, so n, if n's a perfect square, and I'm letting n be the perfect square. If n is the perfect square, then it can't have a factor of 101 because there's no other factors. And so the largest perfect square divisor of 99 is 9. And that's our answer. So now let's solve relay number 2, problem 2. Let t be the number you will receive. Compute the greatest prime number that divides this. So this is 8 factorial plus 9 factorial, which is 8 factorial times 1 plus 9, which is equal to 8 factorial times 10. Okay. So then we want to find the largest prime number that divides this. This is not that hard because the largest prime number that divides 8 factorial is 7, and this is 5. So it's going to be 7. So the answer that this is 7, and they'll pass on a 7 to the third person. Okay, so let t be the number you'll receive. Compute the greatest perfect square that divides this. So it's 6 factorial plus 7 factorial plus 8 factorial. And this is equal to 6 factorial times 1 plus 7 times 8, which is equal to 6 factorial times, this is going to be, so 8 plus 56 is 64. And so then it has to divide 720 times 64. And so 64, let's just say the perfect square is like k squared or something. So k, we want to build k. So k can, let's just say that k is a multiple of 8 because we have a factor of 8 right here. So it's 8 times, and then and the largest perfect square that divides 720 is 144. So the answer is, so k is equal to 8 times 12. And so k squared is equal to 96 squared, which is 9,216. Also, if you didn't understand that last step, then the thing is 720 times 64 is equal to 144 times 64 times 5. And 144 times 64 is a perfect square. So then the answer is 144 times 64, which is also 9,216. So the answer to this one's 9,216. So the two final answers are going to be 961 from the first one and 9,216 from the second one. If you like this video, please like and subscribe. Thank you.